Okay. Hi, everyone. My name is Petter, and I'm here with my colleague Steven. And today we would like to talk about the evolution of data observability. We'll break the session into three parts. We'll start with the macro perspective and explain how is AI changing data workflows. We will then zoom into data observability and especially focus on our approach at Sync. And then Steven will jump into the live product demo and explain what we have running in production today with our customers. To start the macro discussion, I think it's useful to anchor everything around the concept of data development lifecycle. Essentially, to deliver data to the business, we have to go through a couple of activities. We have to do planning, where we decide what are the use cases and where are we going to source our data from. We have to do building, where we actually write code for models, metrics, dashboards, and pipelines. And then we have to do testing. So we verify that everything works as intended. Then we do operations, where we bring everything to production. And we have to make sure that these entire pipelines run every day or every hour as intended. And then only then we get to analysis, which is actually where we realize the value. And we can query the data, be it humans or be it tools or automation. Now, important observation, I think, which maybe doesn't surprise us anymore, is that this entire workflow is getting reinvented. AI is making its way into all the areas of the pipeline, and we see that really unprecedented speed of innovation. This is not just driven by advancement in AI, but also very rapid adoption across the companies and the user bases. The workflow will change, and we believe this is not going to take too long, definitely not years. We think this is actually coming in a few quarters. To explain what we see happening, I wanted to break it down into a few more specific areas. On one side, we've seen a lot of innovation in AI and data analytics. It all started with solutions such as text to SQL. But if you look at what's happening now, we actually see the major Gen AI platforms building entire solutions for data analysis. So we can now ask more sophisticated questions and even analyze more and more complex data sets. And we should expect that this is going to keep moving very fast. On the other side, we see improvements in AI coding. And so we see a lot of progress in how code is being written. We've seen radical transformation in software engineering in the last 2 quarters. And we see this is coming to data engineering too. We went from relatively simple coding completion to actually having coding agents, which are taking entire tasks away and then coming back with pull requests. This is a completely different way to build software. And finally, there is a gap in between. And this is where we see evolution of data observability going. We call it AI SRE, where we're building solutions which are helping teams prevent data issues, resolve data issues as quickly as possible, and ultimately completing the AI investment into the entire lifecycle, where we're helping the teams make sure the data they deliver is reliable. Another angle which is useful to look at is how did actually observability evolve itself, where I guess without surprises, this all started with the foundations where everything was around metadata, where observability is powered by collecting rich pieces of information from the underlying data platform, be it logs or schema or lineage or column level lineage, or its ability to run monitoring for volumes of data, its freshness, or really any arbitrary metrics. But this is just the raw data. And if you think of observability in this way, it's actually missing a lot of functionality. That's why especially last 18 months were about development of workflows. And we've invested a lot in Sync across a number of areas. We've started by anchoring data products into observability to help teams define their critical data assets and use cases. We've changed how teams manage ownership, where we're helping them map teams and data assets and how do they relate to each other, helping them deploy monitors where it actually makes the difference, running incident management, where we actually help teams organize around the situations where data is not working as expected, or giving them quality analytics so we understand where should we invest into quality next. But this is really workflows as we see them today. but we actually see that all of this is getting a next level. We call it the intelligence layer, where entire workflow can be enhanced by AI technology. And ultimately, we see an evolution of each of these workflows with this new technology. We definitely see a future where AI could be helping teams define and identify important data products, or make suggestions of how ownership could be improved, how to deploy monitors, or how to resolve incidents faster, or even acting as a monthly reviewer who is going to review quality and recommend where the investments should go. AI really has a potential to enhance all of these workflows. And this has a profound change because up until today, observability was really seen as a passive component of the data stack. It was sitting on the side, observing what's going on, but it was really not driving the action. With this technology, we see this changing. And so it no longer ends with alert, but rather sophisticated solutions which go deeper into the workflows, automate more work, and ultimately help data practitioners with the reliability of their systems more. But this is going to be a lot of work, and we have been looking around where should we actually start, because there are going to be areas where this technology will drive more impact. We settled in the middle, which is the concept around improving monitoring and around managing incidents. This is what we call the data SRE, or in another way, data quality agent, which is acting as your testing advisor and also helps you automatically diagnose issues. This is based on a number of conversations we had with practitioners, with prospects, and our customers, where we see this continuous challenge of trying to define and deploy the most impactful tests and monitoring. And on the other side, the overwhelming amount of alerts, which many teams have to deal with. And if you combine these two topics, we wanted to create a solution which helps and ultimately helps optimize the testing and monitors, as well as minimizes triage time and resolution time, and taking a lot of that work away. And so what is Scout? What are we actually building? Scout, as of today, is autonomous AI agent. It's focused on data quality, and it can help you recommend the most relevant tests and monitoring, and also acts as a proactive system which is analyzing and resolving data quality issues. You can look at this as two main activities. On one side, I can go to any table in my system, and Scout is able to recommend what would be the best tests and monitors to deploy based on number of metadata and pieces of information. It understands the schema, understands the lineage, usage, downstream use cases, data products, and it puts all of this together to understand where would the test actually make the most impact. The second thing Scout can do is it can triage and automatically handle alerts, and in many cases find the root cause. This is, again, Scout looking at entire metadata from the entire platform and reacting to alerts, which typically would reach a person, but in this case, instead of the engineer having to do the work, Scout does this work for them and comes back with the recommended actions. We then looked at how should we actually build Scout? How would we drive the most value? And we decided that we really need to push for Scout to be fully autonomous. And to explain why, I can explain this into 3 steps of different AI systems we were considering and we see in practice. On the one side, we have chatbots, where we could have built a chatbot where you come to sync and you can converse with our system, and we help you essentially drive the action to the recommended test or to resolve the issue. But we felt that chat interfaces are not so great for these kind of workflows, and they are rather helpful in more like the information retrieval ecosystem with less complex work. We also considered assistant, where essentially solutions like Cursor, which are working essentially alongside engineers, are very helpful assistant, which is constantly iterating with me as I write code and can handle some multi-step workflows, but still keeps me in the loop. But we felt that this is not how observability works. Practitioners are not locked into observability platforms most of the day. And so we felt what's important is that it works fully in the background and it works as an agent. What this means is that Scout runs completely in the background and needs a minimal supervision. That means that it can automate a big chunks of work end to end. It can take an alert and on its own explore lineage, run queries, look at commits, look at all relevant metadata, and come back with the conclusion. There is no human action necessarily needed to trigger the process, which means that Scout is working as autonomously as possible. On the other side, we know that we probably don't want agent but proactively and on its own changing our data platform. And so we made sure that as a data practitioners, you remain in control. Scout will do a big chunks of work on its own, but when it comes to important decisions, we present information back to the practitioner. In this case, we, for example, diagnosed an alert, and it seems like we have to declare an incident. But ultimately, the action is on a person to take. This is where we've collected as much information as we could, saving, in some cases, tens of minutes or, in many cases, hours of work, but ultimately leaving the control for the person to decide what do they want to do next. And finally, we're building Scout to work where you do. That means that in case we, for example, recommend a test, the materialization of the test doesn't have to stay in sync. We, of course, are happy to run these tests for you through our native SQL testing engine. But actually, we believe that in case you're using dbt or SQL Mesh, it's way more practical for these tests to live alongside everything else you have. And so Scout will be opening PRs directly to your code base and ultimately blending closer to your workflow. And so to summarize, what we're building is a data quality agent, a testing advisor, and on-call engineer who can optimize your testing, minimize triage and resolution time, runs fully in the background, and keeps you in control. It will work where you do, so if you have a code base in your favorite transformation platform, you can plug it to that as well. But I think it's enough talking, and I'll hand over to my colleague Steven, who will talk you through how this actually looks in practice.
Perfect. I'm excited to showcase Scout AI live in action. But first, let me set the scene so you're aware of what we're looking into. For context, we built a demo DAG based on publicly accessible New York City taxi dataset. And our approach at Sync anchors data products within the observability layer so that data practitioners can focus on what's important for the business. This could be anything from a finance dashboard or a revenue metric, a end-to-end marketing automation pipeline, or a single BI dashboard in Omni, for example. And the alternative to this view is a catalog of thousands of tables and models without any contextual understanding of importance or use case. The data product status page here is really impactful and enables me to answer some of those tough questions. So I'm logging in the morning. I want to know if my nightly pipelines have run successfully for finance. I can see the status of my product, and I can see the status of the pipeline upstream. Let's take a slightly deeper look. Let's look at our core models, which is a P1 use case. And I'll bring your attention to the top left. As part of this data product, we've logically grouped assets across systems, dbt models, and the associated materialized views in ClickHouse. This is classified as P1, so it's business critical. Data engineering is an owner defined in Sync, or we can put it through metadata as well. And this is the technical accountable owner for any issues that occur. And we have a quality score as well. And what the quality score represents is an aggregation of the performance of controls, with controls being dbt tests, SQL Mesh audits, Sync monitors across 6 of these metrics here, so accuracy, uniqueness through validity. And this is based on controls both on the data product and upstream as well, because we're effectively testing the end-to-end pipelines. And this helps foster a sense of trust and transparency across the organization into data quality. And lastly, in this view, we can see data product level lineage. And this is crucial because table level lineage here would be far too convoluted. We've got customers and partners with tens of thousands of tables. So even business stakeholders, non-technical teams can come in and consume this lineage view and understand in respect of their core model's use case, what resides upstream in terms of ingestion, what resides downstream in terms of finance, marketing, operation, reports, and so forth. But of course, with Sync and with everything at Sync, you can go to a very deep level. And this includes lineage as well. So from data product level, we can also traverse to table level. So we can propagate upstream to sources and also downstream to the BI layer. We can also go to column level, and we can also uniquely as well in the market go to code level. And code level is particularly powerful as you can understand how a column is derived through multiple CTEs in code. And based on working with data practitioners every day, this drastically improves metrics like mean time to resolution. But with that, we are here today to talk about Scout AI. And so I want to navigate to our incident management issue triage. And I'll bring your attention down to the lower part of this screen. And I'll start by reflecting on what the experience looked like before Scout AI. And typically we'd see a test has failed in DBT for not null, or a monitor anomaly has triggered. And the onus at this point would be on the data practitioner to troubleshoot and take the steps to resolve this issue in a timely manner. And through our conversations in the field with thousands of data teams and practitioners, we see the average time to resolution per issue on screen takes about 30 to 40 minutes. And some of the steps to resolution can include correlating issue and incident history, as well as issue interdependency, data analysis such as profiling, sampling, and segmentation, and also reviewing code commits, history, logs, and schema changes. And this takes a lot of time, as you're probably aware, and it takes away from the data practitioner what they really want to be doing, which is building and innovating. So cue Scout, which covers all of the above and more. And you can consider Scout as an always-on data engineer working 24/7, doesn't need to take any PTO or any holiday, and Scout is continually auto-triaging issues within seconds in a codex style. So it's working behind the scenes in the background without any need for any prompts, and it's providing recommendations such as declaring incidents or marking as no action needed. Just to call out here, not every issue is an incident, so that's why we can actually propagate and expedite an incident accordingly. So let's take a deeper look at some of these examples that Scout have auto-triage. So in this case, we can see one of our data products for cost reporting has been impacted. It looks related to revenue, and Scout has summarized this as related to source data corruption. So looking at a deeper level, Scout has provided the actual monitor in question. So we can highlight and see this is a segmented monitor. So we can isolate that on the 10th of June, the revenue for this particular partner, so it's segmented by vendor, Creative Mobile Technologies has gone down to 0, which definitely looks to be an issue. And Scout has actually provided a conclusion into the root cause as well. And this appears to be a data quality issue all the way to the source data, where 0 revenue has been reported despite normal trip volumes. And we can go ahead and expedite the recommendation here on screen, or we don't actually have to take this as face value. We can actually navigate to the evidence, where we can track a timeline of where Scout has actually come across and come to this actual conclusion. And in this case, Scout has actually replicated queries to trace logic from the reporting layer through the aggregate layer all the way to the source layer. And we can indeed see that despite 31,000 trips occurring that day, there's actually 0 revenue reported. So there's definitely an issue with the revenue calculation in this case. So I'm going to trust this recommendation and go ahead and declare an incident related to the linked issues. And automatically the context is propagated into the incident itself. So even then I'm saving more time as well. In the off chance that I don't actually trust this outcome, I can go ahead and re-triage within Scout and provide feedback back to Scout in that instance. So let's take another look at another example here, one that has no action needed. So in this case, there's a DBT test failure on our marketing attribution pipeline. So it looks like a naming standardization issue. And here within Scout, so it's grouped together related issues here. So it's 2 DBT accepted values issues. And based on the conclusion, we can see there's inconsistent naming for Newark Airport. So the code has articulated Newark International, but it's actually expected EWR in the accepted values test. Again, we can check the evidence, and the example here has actually presented a recent code commit that we can understand. And it looks to be a new model has been added for borough popularity in YAML. And the brand new model here has actually caused the mismatch in data values. And we can see that Newark International is represented, but the expected test in DBT requires EWR. It doesn't look like this is a broader data quality impact. It's not impacting anything critical. So we can go ahead, mark as no action needed, and clear this from our immediate triage, but take the advice that we need to go away and tidy up some of our testing for consistency in the future. So within 2 minutes, what we've seen is we've actually saved over an hour's worth of work from all the analysis that Scout's done on our behalf in the background. And getting started with Sync is super straightforward. I'm doing it every day in my role, and I see customers getting connected to their core systems within minutes if you've got the right credentials. And enabling Scout within our settings takes seconds as well. So it's super straightforward to get started. That's everything I wanted to highlight today. But I think we can go back to a couple of slides where I think we've got a customer quote. I don't know whether you got the slides there, Petter, but we've got some customers that are already in production, including Ivan. So Ivan and Stein he's a data engineering manager, and he started his journey with Scout with about 50 issues untriaged, and Scout brought that to 0 in day 1. It filtered out 85% of the noise and gave Stein and his data team the context to handle the rest of the issues extremely quickly, to the extent he's extremely happy to actually go through some of the issues on a day-to-day basis, which is unheard of across the data teams that we work with. And lastly, we also wanted to highlight, in order to get started, it's super straightforward. Navigate to sync.io, where you can book a demo, where you can look at recent webinars, some of our blog posts, how we built Scout from the ground up. And also feel free to contact Petter and myself via LinkedIn directly with any questions as well. And feel free to fire in any questions in the chat now as well.